Hi everyone, James Tennant with you today, and today's webinar is going to be on 2014 Inventor Professional and some of the what's new stuff. So let's get straight into it. The first thing you'll notice when you open up the new version is we have a new splash screen. So this is following on from last year. We have some more interactive tutorials in here which will certainly help those beginners out there. And some really great essential skills videos as well. So that's a little bit new, but you've probably seen all that before. So let's jump straight into a part file and let's get stuck into the nitty-gritty of what's new. In the sketch environment, we have some new sketch features. Nothing too special, but they're quite handy, and that's these sketch slots here. We have a few different methods of inserting a sketch slot, but in my case, if I wanted to just do a normal sketch slot, I can do that. Or I could go ahead and define an arced sketch slot, and that's all pretty straightforward to do as well. Very, very nice tools. Makes your modeling environment nice and easy, and you can go ahead and use your constraints and everything else you want to use in order to define how these sketch slots associate with each other and with other objects. So you can go ahead and use these not just for sheet metal, but also for designing, scissor lift arms or whatever you want to do with it. You can do using these methods. So that's kind of nice. Again, nothing hugely groundbreaking there, but it's a nice incremental advance from the sketch side of things. But the sketch side of things is not the part that's actually had a lot of work done to it. In this case, the assembly and modeling environment has had some huge advancements in this release, which has been very, very welcome. So let's go ahead and just draw something nice and simple like a rectangular box here. And as we go ahead and do that, we also want to just put a profile on the side of things, and this is so that I can show you some of the new features in the feature resolving tools. Now, in previous versions of Inventor, we've had some pretty good sweeping tools and whatnot, but this year they've really been added to hugely. So we've now got some unbelievably good sweeping tools, and in fact we can even do a sweep on a perpendicular plane now. And as you can see, I've just selected two edges, and I can even do that all the way around if I really wanted to. So you can see the sweep tool has been added to significantly, but that's not even the best part. The best part is, let's say I want to go and put a fillet on the edge of that, and I want to sweep around a fillet. In this case, this circle here would normally be far too big to be swept around that edge there. But with the new features, Inventor really has no problem resolving these sort of sweep methods, because we have a new way of resolving them in the equations in the background. So you can see very, very nice tools, extremely good at resolving these sort of things now, and self-intersecting sweeps and curves and whatnot. These can all be resolved now without any problem at all. So we've got some really, really good improvements in the algorithms on how to resolve some of these tools. So that's actually something that I'm personally very, very happy with. There's a lot of improvement in the back end of resolving a lot of features, and this is one of the most obvious ones that you can show. So that's the reason why I like to show it in the demonstration of what's new. So moving right along, so probably not too much more to talk about from the part modeling environment. We will talk about this BIM tab in a moment, because this is going to be extremely useful for those of you that want to exchange data between Inventor and other products, in most cases Revit. But we're going to talk about that in a moment after we get into the big improvements, which is the assembling side of things. So what I'm going to do is I'm just going to go ahead and open up a model. So I'm just going to go and open up my suspension assembly. As you can see, I was using Vault to go and find and open up whatever document I want. Very, very easy way of doing things if you haven't used Vault before. Now, in my case, in this particular model here, I've got a few constraints and whatnot turned on. So when I go and orbit around it and everything like that, this is a small model, it's only 123 parts. But in this case, so we're not having any problem orbiting around this. But when we start getting into huge models, things like 20,000 parts and whatnot, we can actually tell Inventor now to only resolve the biggest components first. So rather than when you orbit around it trying to resolve all the nuts and bolts and all this sort of stuff in the view, we can actually tell Inventor just resolve the big components first. So when I'm orbiting around, all the big components will be resolved, and then when I stop orbiting, the smaller components will start resolving. If you're familiar with the way that Navisworks resolves its parts and whatnot, it looks very similar to that. I'm not actually sure how it works in the back end, but it certainly feels a lot like that does. To change these options, you head over to your display tab in your application options, and this minimum frame rate in Hertz is the one you want to change. So by putting the minimum frame rate all the way up to 20 now, that's actually just telling me when I orbit, when I'm modeling on these massive assemblies, which we'll talk about and probably look at in a little bit. When I'm dealing with those massive assemblies, it resolves parts in a much more intelligent way, based on the size of the actual physical size of the model, so that when I orbit, I can see the outline of the model better, and it just allows me to resolve a lot better. Historically speaking, the maximum for this minimum frame rate was 10. Now it's been pushed out all the way out to 20, which is really nice. And it's not something that it's easily shown on a What's New demo. However, it is something that you'll find tremendous use out of if you're dealing with large assemblies. Speaking of large assemblies, we've got some really unreal tools in large assembly stuff now as well, which you can also have a look into. But we'll talk about those in a little while as well. Moving right along to your constraint side of things, when we now have we now have a way of displaying constraints for any particular component. So for example, if I select on this component and I want to know how is this constrained to this and this, because I know it is constrained because I can see it, but I don't know how it's constrained. Historically, you'd have to go and find that component, have a look down and see the make constraints, and it's not very graphical. But what we can now do is we can now show constraints for this component. By doing that, you can now hover over the constraint and you can see the type of constraint it is just by looking at the glyph there, which is a mate constraint. You can also hover over it to see the solution type, and you can see it's mate, and you can see the same thing down there. If I right click on any of these constraints, I can also see that I can do a drive, I can delete, suppress, edit, or even find in browser, which is really cool. And you can see in the browser you've got this little light bulb next to it, meaning that it is now visible in the screen. If you select hide all, you'll see that it's no longer visible. If I right click on it, I can choose to, well, I can't do it through there, I can do it through here. And that turns that light back on. Visible. I beg your pardon, yes, you can do it through there. Right, so that's really nice that we can actually expose those constraints inside the graphic window and get access to editing them, modifying them, and we can even show all the sick constraints. I don't have any sick constraints currently, but if you did have any constraints that were overruling other constraints or whatever it is, let's say I wanted to go and put in another constraint, I'll make a sick one. Let's go and say I want to constrain that with that edge there, and go OK. Obviously it can't happen, so we'll accept that one, and we now have what's called a sick constraint. If we go and show sick constraints, you can see I've got a constraint here with a little exclamation mark telling me that, hey, this one can't be resolved, which is understandable because I tried to make a mate constraint between something that was already being told to offset. So we can go and right click, delete, and resolve that sick constraint, and you can see that's now disappeared, which is really nice. So that's something that will help anyone that's dealing with models that may have been over-constrained in the past or whatever it is, and you're trying to resolve any of those sick constraints, you can show them all, modify them, and get your model back up and healthy. The other thing we can do in our constraints visibility inside the graphic window is we can actually now, not free rotate, free move the component we want, and as I move it away you can see these little lines that are highlighted now. This is actually telling me that there's 2 or 3 components here that this component has been constrained to. So if I wanted to know how is this constrained, I can see that, well, you've got this line here saying you have a constraint between there and there, and you can see those constraints are now visible. You have a constraint between the face of that and the inside face of this, which is understandable. You have an axis alignment, and you have another constraint here, flush constraint, between that end and probably the rod here, which is exactly what you'd expect. Really nice graphic way of finding all those constraints and finding the relationship between components and how it all works. Hitting the refresh button will send that component back to its normal position. Actually, I should say update button, and those constraint visibilities will be turned off. So really nice way of doing your modeling and at least interrogating your model to find out how something was put together and how to resolve those 6 constraints. Let's jump into a new assembly here, and let's say we want to copy different bits and pieces of this assembly into the new one. Before I do that, I just reminded myself just by hovering over, you'll notice when I hover over this component, it now highlights to me that that's a grounded component just next to my cursor, which I'm sure you'll all identify as the grounded symbol. So hovering over a grounded component will actually highlight next to your cursor that that is a grounded component, and I don't need to start dragging it around before that symbol pops up. So just a nice interface change there, which makes life a little bit easier. But let's go ahead and select a couple of these guys. And that's what I'm going to do. Just select 2 or 3 components, actually probably about 5, and I'm going to go and copy these components. I can use Control-C, or I can just copy, same thing. And let's go ahead and place in those components into a new assembly. Historically, I'm sure you'll all remember that in the past, all those components would have been placed in as individual components, and all relationships between those components would have been lost. In the 2014 release, all relationships between those components are maintained when using the copy-paste tools. In this case, you'll see that this component is still maintaining all of its constraints between any other component that is in the copied selection here. Some of the other components that we didn't copy, like that shaft that we looked at before, those constraints will not come in as sick constraints. They just don't get copied across, which is exactly the way you'd want it to happen. So very handy way of doing things. All constraints work perfectly, exactly the way you'd expect them to. In this case, it looks like there was a constraint that was between another component and this component, but let's go ahead and place a constraint in there. So let's just go and place in that constraint as normal. So that's the old-fashioned way of doing your constraint. Now while I'm in here, let's have a look at some of the new stuff we've got. So we have a new constraint which is called symmetry, which is actually a way of just building 2 components and making them symmetrical around one plane or one other component or whatever it is. So that's actually an exceptionally good tool. Makes everything nice and easy, and you don't have to add about 20 different constraints in order to do that, just the one symmetry constraint. The other one we've got now is an angle constraint. We always had angle constraint obviously, but one thing that is really nice now is the angle constraint is far more graphical. So let's say we wanted to align the vertex with that face there. So once I've done that, you can actually see that graphically it's showing me the angle. So for example, I might type in 20, and you can see the graphic there showing you what the angle is going to be and how it's all going to look, which is a really nice way of doing things. Much better, much more graphical than the angle constraint has been in the past. So that is that's a really good improvement that I'm really happy with. but we don't want an angle constraint in there. We want it a little bit more freely movable. In fact, we don't want any constraints on this component because we're going to go and build it again. So let's go ahead and remove those constraints. And again, we could go and select on that component, show the constraints in here, and remove them through here. And you can see there's a constraint there. Let's go ahead and delete that one. And there's a constraint there, which I've gone ahead and made on the wrong side, but that's okay. So there's the component now being able to move around as you'd expect. So not only do we have advancements in the constraint tools, the ordinary constraint tools like the Symmetry Constraint, we have an entirely new method for constraining components called the joint. So basically, the joint constraints will now do a lot of this automatically for you, and a lot of these make life much simpler for new users to Inventor. So the constraint tool has always been a little bit tricky to get your head around initially. So we now have this joint constraint, which actually makes life really easy. So for example, let's say I wanted to use the joint constraint to create a constraint between this component and that component. All I want to do is align the circles, and by doing so, it'll actually place the component in and animate the degree of freedom that we're allowing the component. And if you missed that animation, you can click animate again, and that again shows the degree of freedom between the component. If you go and select on a different constraint type, and as you can see, it selected the rotational constraint by default, and that's what I'd expect it to do. It recognized what type of components we're dealing with, and recognized that the most likely scenario or constraint that we want to use in this case is the rotational constraint, which is spot on, exactly what I wanted to use. However, if we wanted to make that rigid, for example, we can go and select rigid, and you can see it just does a little animation to say, hey, I can't move anywhere. And again, if you miss that animation, it just says, hey, I'm locked in, I can't move. The rotational we've already looked at. We've got a slider as well, and you can change the angle of that slider if you're not happy with the direction. If you wanted to choose a ball and socket, for example, it would show you how the ball and socket works. So immediately you'll get feedback on what kind of constraint you're actually allowing to happen here. So let's go ahead and allow the rotational constraint, and let's go and accept that. You can see now the component flexes and moves exactly the way I want it to be able to move, which is really nice. Let's go back into the other model and let's grab a part. Now this part won't have any constraints on it because I'm bringing it in individually. So let's go and grab that guy, Control C and Control V in here, and there it is there. And let's go ahead and use that joint constraint and to build a ball and socket joint between this spherical object here and the internal spherical object here. So just go and select on that. You can see, by the way, when I'm doing this, depending on where I'm going to align it, that central area there, the central node of this sphere, is where I actually want to align the central node of this sphere. So by hovering over it, I can see exactly where that alignment is going to happen based on that little green dot. Select on that, and that aligns the two together. It also animates to show you what degree of freedom you have. If you missed it, hit it, play again, and you can see that's the degree of freedom you have. Let's go ahead and accept that one, and let's place in one more. So we have one more ball and socket we want to do, and we can do it in any order. Place it on there, and as soon as I do that, it'll say, actually, sorry, I should clear myself there. If I do it in the order that I just did it there, you can see it's bringing this component to this component. It'll all resolve once you accept that constraint. It'll work just fine. But if you go the other way, it'll bring this component here to this component. So let's just have a look at that just before you discount it. When I bring that component to that component, you can see it now brings it forward. If you do want to flip it around, in this case I probably want to flip it up to the other side, you can use the flip command like that, and you can go and align it to whatever you want. In this case that'll do me, and you can see those constraints jump into place exactly the way I'd expect them to. And just to make sure that it's all working correctly, let's go and have a look at it. And as you can see, all working correctly. If I want to turn it, I can turn it. Everything that I want to be able to do, complete degree of freedom there. Really nice nice way of doing your constraints, and as you can see, it's a very easy way of doing your constraints. You can also see in the bottom here, you can have a look at the constraints just like you would in make constraint and whatnot. If you need to, you can lock those constraints, and that will actually allow no degree of freedom on that, which actually locks that whole component. By unlocking it, you can go and do whatever else you need to do. You've also got this protect section, which actually just goes and says, well, this is a high priority constraint. If I try and use another constraint which is going to conflict with that, basically it's just not going to allow it. It's a protected constraint. So that's also pretty cool. Anyway, that's a little bit about the joint side of things. I can't spend too much time talking about it. I would love to, but we just would run out of time. So that's the joint constraint, which is really good. Historically, if you're interested, this has actually come from Inventor Fusion. So last year in Inventor Fusion we had these same joints, but it was available on the Mac version of Inventor Fusion, which was pretty cool to play around with. But it's nice to see it's come into Inventor now. So that's just a little bit of history about that joint constraint. Let's close that down, and let's close that down. What I'm going to go and do now is I'm going to open up a model that's a little bit bigger. So let's go and find it. You can see when I'm using the Vault interface, finding my files and everything is really good, really easy. You really, if you haven't looked at Vault yet, you really need to. It's an exceptional way of managing your data. So now that we've got that component open, so it's now opening it up. It's a bit bigger model. You can see it's about 1,600 components, and you can see you can go and orbit around it and do all the other stuff. But you can see actually it can get a little bit jolty. It's probably not too bad at all, really, considering. But if you wanted to, well, let's say you had 10 of these in the same model. What you can actually now do is load this model using what's called an express mode. Express mode is kind of similar to a level of detail, but an automated level of detail. So by loading an express mode, you're actually telling Inventor, there's a whole heap of little components that I just don't care about right now. Get rid of them. I don't want to see them. Express mode actually just goes and saves all the data about what components are visible in express mode and what components are not visible in express mode in the assembly file itself. So when you go and load express mode, and if you're interested, express mode can be found from here. Once you go and load express mode, you'll find that the assembly file might grow, might get a little bit bigger, because all the data about what component is visible, what component is not visible, is actually loaded to the assembly file itself, which is a really intelligent way of actually holding that data. So let's go ahead and load express mode and go ahead and do any saving that it requires me to do. It'll go and reopen the component using express mode, and that's what it's doing now. And once it's in express mode, or once express mode has been loaded, you can then go ahead and move around the component. You can see it hasn't really made a huge difference because Inventor is actually quite good at resolving big assemblies anyway, but you can see it has made a bit of a difference. You will see a massive difference in your really big assemblies. 1,600 parts these days is not a big assembly, but really big assemblies like 100,000, 200,000, you'll see a massive difference in the usability of your model. So that's something to do, something to play with. You can see in express mode we still have a lot of our functionality. We can still go and do a lot of assembling, placing components in, this and that, whatever you need to do. It's exceptionally functional still, so that's something to keep in mind. Speaking of placing in components, let's have a look at placing in a component. I'm just going to go and grab any old assembly here. I don't really mind what it is. I have no idea what it is, to be honest. This will do. You can see that when I go to place in that component, what you'll now get, and even if you have a brand new assembly open, what you'll now get is this option here to place the component wherever you want. So it's not going to automatically ground itself to the root of the assembly file, the first component. It's actually going to come up and tell me where do you want it. And what you'll notice is you've got this little UCS sitting on there. So that UCS, we can now go and align things. So in this case, this is a vertical member, and you can see it's lying horizontally. So we want to go and rotate it around the x-axis. So I just go and right click and choose rotate around x-axis, and you can see I can go and rotate it. Very, very easy to do. Make sure it's in the right configuration or orientation from the very start. If you did want to just ground and root it from the start, you can see place grounded at origin, and that's how you would go and do that. But you can go and rotate it around whatever axis you want, and it'll do whatever you need it to do. So very, very nice way of placing any components, and you can still get access to the old way if you need to, which is really good. Speaking of Express mode, once we've saved that as Express mode, let's close it down. And we don't want to save it because I've already opened it up as Express mode. We know what the component name is, so let's go and find it. There it is there, and go to Options. And that's where you'll see the Open Express now. In here you can go and select Open Express, which will go and open it in Express mode automatically now. So you don't have to go and swap to Express mode from the open screen. Once Express mode has been instigated and saved, you can then go and open it as Express mode anytime you like. And you can see you've even got an Express view here, where you can go and change between Express view and normal view as well. Let's go and load full, because we want to do some exchanging now. So I did mention that we've got some nice new BIM exchange tools, and that's what we'll talk about now. So let's start off by jumping over to the Simplify tools. Now, the first thing I want to do is I actually want to get rid of some of the components in here, because we've got a lot of components that I really don't care about at this stage. A lot of internal components that tools like Revit really don't care about. We only want to know the envelope or the envelope of the entire model. So to start building this up and simplifying it, we need to go and make a view, and because we don't want to override the master or the default. So let's go and make a new view and start including what components we want. So I'm just going to go and select the Include Components tool. This will load up a tool which will allow me to go and pick what components I want to keep, basically. So in this case, if I've got my little heads-up display here, which I can go and move, do whatever I want to. I can go and select on what components I want to keep. I can also change that to a component priority. So I'm just going to select component priority and select on the outside container here, because I want to keep that. Once I've selected on that, I can then go and include selected parts as well. So I'm just going to select on each of these exhausts. And I've also got a part around the other side that I want to have a look at as well. So that's this part here and this part here. Great. Once I go OK, in that view it'll get rid of everything except for the components that I've selected, which will lighten that load massively. There it is there. And I'm now left with only the components that I wanted. You can see all the internals and everything have all been cleaned out, reducing the size of the model, reducing the size of the view, I should say. Right, so we've now included only selected components, but we still have a lot more detail here than I actually want. So from here I can now go and define envelope, and I might just select on this bottom part, or in this case that one there. And I can now, once I've selected that component, it actually goes and builds a model around it. So it goes and builds a basic box shape. You can actually tell it to build a cylindrical shape, which we'll do in a moment, but in this case we've selected box. Once we've done that, we can then use these arrows to dynamically change the size of it. We can type in exact numbers, or we can just use the faces to define exactly how big it is. I have no idea how tall that is, so I've just selected on the top face to say, you know what, I don't care how tall it is, I just want the envelope to stop at a certain point. Let's go and select there. Everything else should be pretty good, so let's go ahead and accept that. But before we accept that, let's go and make sure that it's made out of the right material. You can go and choose a material in here, or you can go and select on a different material and say whatever that is, make it the same, which is nice. I'm going to go and do that. Okay, so there's your envelope. It's just gone and built. It's left the other model there because it doesn't know whether you want to go and build more parts of it. If you wanted to remove visibility from that component, you can just go and do that from here and right click and change the visibility to none, simplifying your model significantly. We've still got a couple of pipes here and we've still got these exhausts. So let's go and define another envelope, and this time we're going to choose cylindrical and select on that. Again, it's gone and recognized about the right size, and to be honest, I don't really need to make any changes at all to that. So we've also got the option to follow a pattern, and in this case we've got a pattern for all these. So let's go ahead and go OK, and it's gone and changed all of them to those flutes that I wanted them to be. And finally, beg your pardon, not include components, we want to define envelope. So let's wait for that to reload. Okay, so once you've got all those envelopes defined, like I do now, actually I've got one more to do on the other side, and that's these input-output pipes. So let's go ahead and go and define an envelope for those ones. These ones are a little bit different because they're an odd-shaped component. In this case, it's a pipe that turns around a corner. So what we will need to do is realign the axes of this particular cylindrical object to suit the size of the pipe, and I'm also going to realign the size of it as well. One of the really nice parts about this is actually it's detecting the colors and everything every time. So let's go ahead and go OK. It'll do both of those, as you can see, leaving me with, and in this case now I can go and turn off the rest of the components so that I know everything else in here is absolutely necessary. It's only those envelopes that I want left. So even if I've got other components in here, I just turn the visibility of all of them off so that I'm actually only simplifying these envelopes left in my browser here. And speaking of simplification, that's what we want to do now. So we're going to create a simplified part, and I'm just going to click OK to those default settings. Once you've created that simplified part, it will basically build a derived part out of that component. And that's what it's done. The moment you do that, it'll send you into these BIM tools. So I've got a brand new part here. It sends you into these BIM tools and automatically does this recognize Revit features here, which is really cool. So basically what this has now done is we've gone ahead and recognized all Revit features. So it's gone and built extrusion after extrusion after extrusion, revolves, sweeps. You can do almost anything in here. It will automatically recognize everything, so that when you take that over to Revit, everything is going to work just nice. You can go and check the Revit features as well, which will actually just go and check it, make sure it all works. Very good. When you go to BIM Exchange now, we can now go ahead and do any other tools we need to. So that is now all working really well. BIM Exchange. And now let's go ahead and choose the pipe. So I want to place a pipe connector in here and choose that. And another pipe connector. Let's go and do cold water again, but this time we'll go the other direction. You get the idea. So you've all used these tools before, no doubt, if you've been in this area for a while. And let's go and export components. Must save it first, of course. And when you do that, you'll see you've got this option here to export Revit family. So you can see there's the option there. So Revit family files or ADSK. Really, really nice. So we can now do direct to Revit. Before we do this, I would probably recommend that we realign that UCS to suit whatever we need. Now, if we didn't want the UCS there, we could go and define our own UCS, which is a really straightforward process. So that if that's where we want the UCS, we can do that. If we want the UCS somewhere else, we just place it there. When we go to export Revit components, now we have the option to choose UCS1, which is where we want to export from. Choose whatever you want. I'm not even going to look at what I'm choosing. I'm just going to go and select it. And you can see all your options there. You can see the checks that are running as well. So you can see we've got a design check here, which tells me that everything looks good, and we've got a level of complexity is low. We've got number of faces and all sorts of stuff in there, which is all really important. We check the Revit models, everything looks good. So we're now able to output that whole thing direct to Revit, which works really, really well. I'm not going to show you importing it into Revit because I don't know Revit well enough. So that's how to do it, at least, anyway. So that's some of the Revit tools and everything. They're excellent way of doing things. Really, really good way of exporting and getting everything into a good environment for the Revit users to use. The only thing I want to talk about now, and it's probably the only thing left to talk about, actually there's quite a lot, and I'd recommend you go to the What's New area. So if you haven't already, head over to the What's New section, and that will show you any of the other stuff that I may have missed. However, the only thing left to talk about is your cloud account and how to use the cloud to manage your data. One of the really cool things we can now do inside of Inventor is we can manage all of our Inventor files in your A360 account. When you install the 2014 product, you'll now get this option here, and it turns up like a device in your computer. So when you look in here, you can now see that I've got files in here. So I've got my project file and everything set up correctly. You can see there's little tick boxes here telling me that all the components are now synced perfectly with the cloud account. You have 25 gig of cloud data, I think, by default. So plenty of room in there, and it basically behaves just like Dropbox would. So when you go and open up something, it'll sync it back, or it'll sync the changes you make back to the cloud. So it's a really nice way for a single user that wants to collaborate at home to get their data a little bit more mobile. One of the other really nice parts is that if you go and open up something from here that has references, or you try and load something that has references, it is actually able to interrogate those references before you put it in, or if you wanted to get something out of the cloud, it's able to interrogate all those references, which is really, really cool. Now if I wanted to go and have a look at it, I can go and choose the share account, open account. If I wanted to share that with someone else, it will take me to my cloud account where I can go and share that component with a specific user, and that will also share any related data that they need to share as well. If I wanted to download a component direct from this this page, I can go and select on that, and it'll download. Let's have a look at all my docs. So let's say I wanted to go and download an assembly here. So let's go and find an assembly. So in our case, we're looking for this guy here, for example. If I wanted to go and download this assembly here, what I would find in the new cloud account is it would interrogate all those references and make sure all the files that I needed were downloaded and not just the assembly file. So there's been some really good enhancements to the cloud account. So take a look at it. It's a really nice way of doing things now. But yeah, so that's something to take advantage of. Alright, well that's about it for today's webinar. I've nearly run out of time, but thanks very much for everyone watching, and I'll talk to you soon.